Assalamualaikum warahmatullahi wabarakatuh. My name is Shafika Nadia binti Safarudin. My matric number is CE 210116. Today I'm going to do a presentation for my final project title, which is called Leaf Disease Detection System using YOLOV11. So for your information, my supervisor's name is Dr. Nick Shahida Afifi binti Muhammad Tarjuddin, and my co-supervisor's name is Dr. Suhaila binti Sari. So I will start with background of study. So corn is a vital global crop, serving as a key food sources and industrial raw material. So cod leaf disease significantly affect crop yield and quality. So three common cod leaf disease in Malaysia is include by first cod leaf blight, second grey leaf spot, and the third is cod leaf rust. So these fungal disease have been reported in Peninsular Malaysia and Sabah, leading to major yield losses. So for the project goal is to develop a cod leaf disease detection system using YOLO plus CNN, and also the system is aimed to enhance detection, speed and accuracy, improving crop management and yield. Okay, for the problem statement, although corn is very important for agriculture and food, we know that disease that affect its leaf can impair its health and quality. So the proper handling of this disease depends on early detection. We know that traditional approach depend on what are often slow and imprecious visual checkup. So it means that we need to having an automated system to recognize and classify cod leaf disease. So by having the automated system, uh, they can use this and they can use it in real time. Uh, so it also provide useful info for the farmers and assist them in boosting their crop well-being and yield. For the objective, first is to detect the disease on corn leaf by using YOLOV11. So I achieved this by successfully implemented YOLOV11 to detect corn leaf disease, including common rust, knotted leaf blight, and also healthy, and also achieve high performance with F1 score of 0.93, precision of 0.94, and recall of 0.92 at each 100. Second objective is to evaluate the performance of precision, time and accuracy of the disease detection. I achieved this objective by conducting a comparative analysis of YOLO V8, YOLO V9, and YOLO V11 model across 50, 100, and 150 POSH. So YOLO V11 outperformed the others in terms of accuracy, train time, and detection robustness, particularly in disease-specific case like common rust detection, which is the precision is 0.963 and the F1 score is 0.947. And the last objective is to design a Android application to assist the farmer to detect chronic leaf disease. So I achieved this by developing a model application named Card Leafer using Visual Studio Code and using Tuckable and also Tiny Host. And I also integrate the trade model that I use in RoboFlow app, uh, and using the RoboFlow API key for real-time detection and include features such as live detection via phone camera, class-based recommendation tips, and also timestamp and location-based logging. For the scope of project, the system is to detect cod leaf disease based on the color and spot patterns, and also the cod leaf that will be detect are leaf that affect with common rust, total leaf blight, and also healthy leaf. The number of dataset that I use for training, validate, and test that focus on this disease of the cod leaf is healthy by using 1,000 dataset. Total leaf blight also using 1,000 dataset, and common rust disease also use 1,000 dataset. And the detection system that I use is Google Colab, developed at Google Colab, which is the training. And also the last one is Visual Studio Code that will be used to develop the application of cognitive disease detection on the phone and to do the performance evaluation of precision, time, and accuracy. This is the flowchart of the project. So first is we need to collect the dataset, cognitive dataset of three disease, and after that we will upload it into the RoboFlow, and we will do a image segmentation and image augmentation. So after we apply this, the dataset will become bigger and much more, like from 3,000 to 6,000. And then we going to do testing and validate. I will divide it by 80, 10, 10. So after go through training and validate, I will look at the model accuracy and the loss. So if the model accuracy is more than 80% and the loss is lower than 1%, I will continue to model testing, and I will do a classification, and then we'll use the data set to do a application development at Visual Studio. But if the model accuracy is below than 80 and the loss is more than 1, I will repeat the training again. So I will repeat to train the dataset until it becomes accuracy more than 80 and loss below the 1. So after that, I will proceed to the next step, which is to develop the application using the dataset that have the accuracy higher than 80 and loss lower than 1. So that's it. For Android application development, the first picture is the logo of Codeliver, and the right one is the home screen of Codeliver, and also contain the start scan button. This is the result after I write the application and do the detection process. So as you can see, the first photo is detect the disease, which is we have three diseases here: first disease, latent disease, and healthy. It contain disease detection result and also confidence level. And that's we second photo we can see it detects detection timestamp, which is state that it last detected on 28 May and also 8:39 p.m. So we will know where it detect the do the detection result when. And lastly, last photo is it also detect the location based logging, where it have longitude and latitude of the location. And also I add the features of recommendation tips for each class. So for us, it has these recommendation tips and also noted and healthy. So it will help farmer to take action after they detect the disease on the corn leaf. Okay, for the conclusion of future work, combining YOLOV11 with mobile apps shows that monitoring plant disease in field can be greatly improving the system. And the app also reliably detects common rust, noted leaf blight, and also healthy leaves. So the addition of the feature makes the application advise customer based on their present location, and it also become a tool farmer can use to help decision making, and also can be used as a starting point for other crop monitoring tools. So for the recommendation for future work, I recommend to expand the data set, which is a greater amount of crop leaf disease data and a wider selection of how disease show system symptoms. So this action will help the model correctly divide keys outside the main one and decrease incorrect classification. Second idea is improve the detection in diverse conditions. So improve the model's ability to work with different lighting, noise, and leaf position to achieve steady performance in agriculture environments. And the third is add offline functionalities. We provide offline ways or an SMS service to inform users in less connected areas so that the app is fair for all. And the last one is improve geolocation accuracy, which is make full use of GPS to improve the accuracy locating disease outbreaks and precision farming practice. That's all from me. Thank you.